Energy companies want to improve operations and keep their employees safe. But it is never easy. Machinery breaks and someone has to go fix it. Picture yourself 200 feet in the air on an icy oil rig. These repairs are not only expensive, but also dangerous. Now, companies know that by better analyzing their data, they can improve their operations, thereby saving money and keeping their employees safer. But there's a challenge. Only 20% of the data needed for this analysis is in a structured format, like spreadsheets or databases. That's data that computers can easily use. The other 80% of it is in the form of text, like repair manuals, injury reports, and notes jotted down by technicians. This information is extremely valuable, but due to its size and structure, it has largely been invisible to analytics teams. Imagine you're searching a database of injury reports. You want to find lower body injuries. What do you search? Analysis from one large utility company showed that lower body injuries returned only a small number of results, far fewer than existed in reality. That's because their search tool was looking for the exact keywords, lower body injuries. But when the analysts used more specific search terms, like foot injuries, that returned many more results, where foot was used in the context of distance. So while they had more results than searching for just lower body injuries, they weren't the results they wanted. This was because a foot can be both a body part and a unit of measurement. And while humans can determine context and know the difference, until recently computers were largely stumped. Thanks to this field of AI, called natural language processing, computers can now analyze and understand textual data. In case you're curious, here's how natural language processing works at a high level. NLP algorithms can't read text like we do, but they can look for patterns, and they find these patterns by turning huge amounts of text into matrices. When analyzing text, the algorithm might first remove words that don't really offer us much value, stuff like a, the, is, and are. These are called stop words. Then the algorithm might split the sentences into groups of words and count how many times each group of words appears in each document, and how many documents have that group of words out of all the documents being analyzed. Without knowing anything at all about the text, the algorithm can then tell how often a given word or phrase appears in a given document, and how many documents contain that phrase out of all of the documents. So tokens that appear lots of times in lots of documents may not mean much, but tokens that appear frequently in only a few documents tell us that something is going on. For example, if we fed injury reports across all of our oil wells into this basic algorithm, and we see that falling debris injuries are clustered around reports from rigs in the Gulf of Mexico, we might then know about a new piece of machinery or process or environmental condition or something else that is causing injuries before management hears about it. Now, this is just a basic example. When combining vast amounts of data and advanced NLP algorithms developed at Spark Cognition, our customers are seeing tremendous improvements in operational efficiency and safety. Wind turbine operators are finding answers that previous solutions missed. Spark Cognition finds the meaning in the data and makes that available. Oil and gas operators are able to ask natural language questions when performing diagnostics before repairs. So with advanced technology like Deep NLP from Spark Cognition, you can now unlock the value of your unstructured data. Every email, every maintenance log, and every injury report become actionable insights that can drive revenue and reduce costs. And it's not just the energy industry that can harness the power of Deep NLP. If you want to learn more about how Spark Cognition can help you generate value from your unstructured data, please keep reading at sparkcognition.com.